Questions 21 through 25 on the 2002 Grade 10 Cayley Math Contest. In the diagram, the circle has center O. The shaded sector AOB has sector angle 90 degrees, and AB has arc length 2 pi units. The area of sector AOB is. So they are telling you that this arc right here is 2 pi in terms of its length. So we all know that the circumference of a circle is equal to pi times diameter. And if you put that in terms of radius, since the diameter is equal to 2 times the radius, it's pi 2r, like that. And this is 90 degrees. So that segment, that arc AB, is basically a quarter of the full circumference. And what I like to do is write it in terms of angles. So 90 over 360 degrees, right? The full all the way around is 360, and I've got 90 in my shaded area. So this is the ratio of the circumference. That is equal to 2 pi. Now 90 over 360 is 1/4, which is pretty much exactly what I had said before, that it's a quarter. And the circumference I will write in terms of pi, like that. And that is equal to 2 pi. That's the distance of the arc AB. Now this helps me because it helps me solve for r. The pi's canceled, and that leaves just 2r over 4 is equal to 2. And that means r is equal to 4. So there is a very important part of the question. Now they want you to find the area of that sector. Well, the area of the full circle, of course, is pi r squared, but we have a quarter of that circle. So it would be pi r squared over 4, area of the shaded region, AS. So pi r squared, r is 4, all over 4, and therefore this looks like 16 pi over 4, which is 4 pi. So 4 pi is your answer to number 21, and that would be A. In how many different ways can 75 be expressed as the sum of 2 or more consecutive positive integers? So let's start with 2. If it's the sum of 2 consecutive positive integers, it's n plus 1 is equal to 75. And therefore that would mean 2n plus 1 is 75. And solving this, you would get n is equal to 37. So that means our two numbers would be 37 and 38. So that's one way of making 75 as the sum of 2 or more positive consecutive integers. Now let's start by looking at other possible combinations. So the next one is going to be 3 integers, n plus 1, n plus 2, like that. So this was 2. This is going to be 3 consecutive integers, and that equals 75. So this looks like 3n plus 3 is equal to 75, and therefore solving for n, you'll get n is equal to 24. So this gives us 24, 25, and 26 as 3 integers that, when you add them up, gives you a sum of 75. So we've got another way. One way, two ways. Let's keep going here. How about when you have 4 consecutive integers? Well, this will be n plus 1 plus n plus 2 plus n plus 3 is equal to 75. And that is 4n plus 6 is 75. And therefore n is equal to 17.25. Well, that's not an integer, right? So unfortunately, that one is no good. How about 5 consecutive integers? I'll save the n plus 1, and you get the point. The sum of 5 is basically 5n plus 10 is equal to 75, and therefore n would equal 13. So that means our 5 consecutive integers are 13, 14, 15, 16, and 17. So there you have it. We've got another possible way of doing this. How about if you have 6 consecutive integers? Then you'll have a sum that is 6n plus 15 equals 75, and therefore n is going to be 10. And therefore our integers will be 10, 11, 12, 13, 14, 15. So we got another way. Okay, so far so good. Any more? Well, when we have 7 consecutive integers, it becomes 7n plus 21 is 75, and n becomes 7.71. So n is not an integer, that's no good. If we have 8 consecutive integers, our sum becomes 8n plus 28 equals 75, and n becomes 5.8 approximately, so that's no good. How about 9 consecutive integers? Our sum becomes 9n plus 36 is equal to 75, and n is going to be about 4.3. So no good there. How about 10 consecutive integers? 10n plus 45 is equal to 75, n is equal to 3. So that's an integer, and therefore our list is 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And for the sake of time, I will allow you to do 10 equal 11 consecutive, 12 consecutive, blah, 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 and so on. And you'll find that there is no such additional ways of doing this. So what I've done exhausts the possibilities. So how many ways did this work? 1 way, 2 way, 3, 4, and finally 5. So number 22, the answer is 5, which is choice E. In trapezoid ABCD, AD is parallel to BC. Also, BD is perpendicular to DC. The point F is chosen on the line BD so that AF is perpendicular to BD. AF is extended to meet BC at point E if AB is equal to 41, AD is equal to 50, and BF is equal to 9. What is the area of quadrilateral FECD? So they want you to find the area of FECD, that shape right there. So let's try to solve this without making the diagram too messy. AB is 41, and AD up top here is 50, and BF, this small space there, is 9. So these are all right triangles, right? This is 90 degrees right there. And therefore this is 90 degrees also. And they also tell you that that's 90 degrees. So we basically have a lot of 90 degrees everywhere. So that basically means that we have a lot of Pythagorean theorems everywhere. So the first thing I'm going to do is figure out the area or the length of AF. And I can do that with Pythagorean theorem on this triangle right here, right there. So that will be AF squared is equal to, well, AF plus 9 squared is equal to 41 squared, like that. And therefore that means AF squared is equal to, we've got 1681 for 41 squared minus 81 for 9 squared. And this looks like 1600. And therefore 40 is equal to AF. So put that in there, 40. That's my first calculation. Now what else can I get? Probably FD using Pythagoras, since that's a right triangle. This length of FD, that's going to be possible. So 40 squared plus FD squared is equal to 50 squared. So FD squared is equal to 2500 minus 1600. and that's 900, so therefore FD is 30. So put that in there, right there, 30. And then now I'm going to connect a line. It might not seem necessary, but just to kind of look at this a little bit better, D to E like that. And what I'm going to do next is a relationship between the diagonals of that shape. So the diagonals I'm referring to are A to E and B to D. The ratio or the relationship is that AF over FE, so AF right there over FE, is equal to DF over FB, like that. DF over FB. So do we have our values? AF is 40, FE is what we're probably figuring out here. DF we know is 30 and FB is 9. So if you do this, you'll get FE is equal to 40 times 9 all over 30. And therefore that means that FE is 12. So put that in there. Right there, like that. And now one step that needs to happen is we need to draw a line from E right here to meet this guy DC, but I'm going to draw the line exactly parallel to DF like this. Okay, exactly parallel to DF, making this a right angle and that a right angle. So this is exactly parallel. And when you do that, I hope you can see that it makes this side, or that length, 12. Exactly the same as FE. And it makes this side, right here, 30. Exactly the same as that 30 right there. Okay? And then the final step to this question is to understand the following. Note something that's very important in this question, that AE is perpendicular to BD, correct? This is AE right here, and it's perpendicular to BD right there. And there's a whole bunch of right angles there, so you should be convinced of that. And also, DC is perpendicular to BD. DC is this guy right here. It's also perpendicular to BD. And that right angle pretty much proves that. So what does that mean if you have these two conditions? It means the following, that AEDC is a parallelogram. And that's a very important conclusion in this question, because since it's a parallelogram, these two sides are the same in terms of length, AE and DC. So since A to E is 52, 40 plus 12, DC is also 52 from D to C. And therefore, since that segment in there is 12, this segment has to be 40, like that. And this is, of course, a right angle right there. And there you go. We have everything we need to figure out the area of FECD. FECD. That shape. We have everything we need. I think I won't need much more than that much space. Break it up into two segments. We've got the triangle and we've got the rectangle. So the triangle is just 1/2 base times height. So this is FECD. 1/2 base. The base you can write as 40. The height you can write as 30. Either way, it doesn't matter. Add to that the area of the rectangle, which is just 12 times 30. And that will give you the full area. And that becomes 360 plus 600. which is 960. So there you go. 960, number 23, answer is C. A cylinder which has a diameter of 27 and a height of 30 contains two lead spheres with radii 6 and 9, with the larger sphere sitting on the bottom of the cylinder, as shown. Water is then poured into the cylinder so that it just covers both spheres. The volume of water required is. So the first thing I'm going to do is draw a cross section of this diagram. So here you have the cylinder and you've got the two lead spheres, just a cross section, and they're going to pour water in so that it covers both of those spheres all the way to the top of that smaller sphere. So both spheres are basically submerged in this water. And basically this is all water now. Okay? Like that. Now I'm going to need to figure out a bunch of areas here, so I will remove all those lines, but I'll keep the top one to let you know that that is the level of the water. Now we have to label a bunch of radii so that we can figure out some very important distances. So the first thing I'm going to do is draw lines from the center of each circle like that, and let's start labeling what we know. We know that the radius of the small circle is 6. So that's 6, that's 6, and that's 6. We know that the radius of the large circle is 9. So that's 9, this is 9, and this is 9. Okay? And therefore this is 9, this is 6, and this is 6. And we also know that the diameter of the cylinder, which they also labeled there in the initial figure, is 27. So that means from here to here, this whole distance is 27. So this segment will be 27 minus 6 minus 9, which is 12. Okay? And therefore that distance is also 12. And this distance from top to bottom, that distance I don't know yet, so I will call x. And then this is a right triangle. So I can then now use the Pythagorean theorem to figure out x. So we have x squared plus 12 squared is equal to the hypotenuse squared, and the length of the hypotenuse is 6 plus 9, all squared. It's basically the two radii added together. So this becomes x squared is equal to 15 squared minus 12 squared, and that is 81, and therefore x is equal to 9. So this distance is 9. So if I write all the numbers on the side, like here, this is 6. From here to here, we just figured out that's 9. And from here to here, we know that's 9 because it's the same as the radius right there. It means that this whole side is equal to 6 plus 9, which is 24. And that is the height of the water in this diagram. So now what do we have to figure out in this question? How much water is in this cylinder to that level? Okay, I don't want to mess this up too much, but you get the point. The water obviously cannot be inside those green circles because those green circles represent lead spheres that obviously water cannot go inside. So to calculate the volume of water, we would have to first calculate the volume of the cylinder and then subtract from it the volume of the two spheres. So we'll do that here. Volume of water, VW, is equal to the volume of the cylinder minus the volume of sphere 1 minus volume of sphere 2. And that should do it. So the volume of the cylinder is pi r squared times height. the volume of a sphere, just in case you don't know the formula, is 4 over 3 pi r cubed. So VS1 would basically be equal to 4 over 3 pi r1 cubed, and the volume of sphere 2 is 4 over 3 pi r2 cubed, like that. So pi r squared h, what is the radius of the cylinder? Well, the diameter is 27, so the radius is half of that, 27 over 2 squared. The height, well, the height we figured out was 24. That's the height of the water in that tank. So we have 24 for the height. And then these spheres, the small sphere had a radius of 6, and the large sphere had a radius of 9. So we can factor out a pi, since that is common to everything. And then now we just do the math. 27 over 2 squared times 24. That looks like 729 over 4 times 24. And this is minus 4/3 6 cubed, which is 216. Minus 4 over 3 9 cubed, which is 729. And then this is just some number crunching here. This is going to be 4374 minus 288 minus 972. And if you do that math, you'll get 3114 pi. 3114 pi is the answer, and that represents the amount of water in this diagram, and therefore that would be answer D. A lattice point is a point xy where both x and y are integers. For how many different integer values of k will the two lines kx minus 5y plus 7 equals 0 and k squared x minus 5y plus 1 equals 0 intersect at a lattice point? So we have kx minus 5y plus 7 is 0, and we have k squared x minus 5y plus 1 is 0. So let's solve for y in each case. So this becomes kx plus 7 is equal to 5y, and therefore y is equal to kx over 5 plus 7 over 5. That's our first equation. Next one, we'll have k squared x plus 1 is equal to 5y, and very similarly, y is equal to k squared x over 5 plus 1 over 5. We got two ways of representing y, so you let them equal to each other. Kx over 5 plus 7 over 5 is equal to k squared x over 5 plus 1 over 5. Put everything on one side here, so we got kx squared over 5 minus kx over 5, and then this looks like 1 over 5 minus 7 over 5, so minus 6 over 5 is 0. Factor out an x, and you're going to get k squared minus k over 5, like that, x, minus 6 over 5, and that's 0. Move this up. Put the 6 over 5 on one side, k squared minus k over 5x. And then we'll isolate for x. So cross multiply and you'll get 6. Actually, we can cancel out the 5's. So this just becomes 6 over k squared minus k, like that. And that's it. We can factor the bottom and we'll get k times k minus 1. And there you have it. Now, one very important point is that x and y are both integers. So I'm going to write that in there, integer, x and y. So now we have to figure out how many times we can start plugging in values of k to make x an integer, and then y is going to be an integer. So once we get x, we're going to have to plug it in back into here, the values of x and k, to figure out y. And if both x and y are integers, then that value of k is what we are looking for. So let's do that. Let's make a table, and off we go. So our table is k, x, and y. All right. Now, one important thing, of course, is where do we start, right? I mean, there's infinite values for k. 500, 200, 6, minus 3. Where do we start? What is the boundaries of k? That will definitely help us. Well, x is an integer, correct? So if x is an integer, the denominator must be 6 or less. If the denominator is greater than 6, that will be a fraction, correct? So that means k has got to be less than or equal to 6. I mean, I know the denominator has to be less than or equal to 6, but at least k has to be less than or equal to 6. So that's a pretty good boundary. And then similarly, the denominator has to be greater than negative 6, because if it was negative 7, negative 8, this would become a fraction again, right? Same principle. So k has to be greater than negative 6. All right? I'm not saying that k is equal to 6. I'm just saying that these are the boundaries, and that helps us, right? Just less numbers that we have to keep plugging in, because this is a math contest. You don't have a lot of time. So let's do that. We'll make a table: 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. All right? Let's start plugging values in. Immediately I notice that if k is 0, this is going to be undefined. So that's not going to work. If k is 1, similarly, it's undefined. So we've eliminated two possible values of k. And you just start plugging in values and get, a result and see if it's an integer. When k is 6, x becomes 0.2. Is that an integer? No. So we don't need to figure out the value of y. Both x and y have to be integers in order for this to be a lattice point, according to the question. A lattice point where both x and y are integers. So that's what we're interested in. All right, let's keep going for this expression. When k is equal to 5, this becomes 0.3. So, no good. When k is 4, this becomes 0.5, the value of x. When k is 3, this becomes 1. All right, great. So now we can substitute 1 and our value for k back into here and figure out the value of y. And if you do that, you'll find that y for k equal to 3 is equal to 2. So there you go. We've got one lattice point. When k is 2, x becomes 3. But y becomes 13 over 5. So unfortunately, that's no good. Moving down to negative 1, x becomes 3, but y is going to be 4 over 5. So no good. Both have to be integers. Negative 2 for k, you get 1 for x, and you get 1 for y. So that is another lattice point. When k is negative 3, you get 0.5 for x, so no good. Negative 4 gives you 0.3. Negative 5 gives you 0.2. And negative 6 gives you 0.14 approximately. So there you have it. You've got all the values, and the only ones that give you integer solutions for x and y are k equals 3 and k equals negative 2. So we only have two possible values of k for which we get lattice points. So therefore, number 25, the answer is 2. integer values of k, and therefore that would be choice B.